All right, well, good morning. My name is Roy Swart, and the talk today is what apologetics can learn from science, case studies from a high-tech scientist. So I have been working in the field of semiconductor research for almost 30 years. I started at Intel in 1997. So if you do the math, it's not quite 30 years, but almost. And I've been doing various, mechanical engineering, electrical engineering, material science, physics, chemistry, quite a cross-discipline career over those last 30 years. So we are here. In the beginning, somebody said, I wanted to come to this talk specifically because I've often heard the phrase, aren't science and religion, or science and the Bible, or science and Christianity in conflict? Anybody ever heard something like that? All right, 100%. So that's what we're going to talk about today. One of the best examples that people give when they say, well, science and religion, science and the Bible contradict each other, is the example of Galileo. Have you guys ever heard that? They use Galileo. Perfect. So we're going to talk a little bit about that. The story goes something like this. Nobody can actually believe the Bible. It's not meant to be taken seriously, because if you took the Bible literally, you'd have to be a moron. And let me give you an example. Psalm 104:5 says, God placed the earth on its foundation so it can never be moved. So if you actually believed what the Bible said, you'd be like, okay, so the earth is right there, and it's like it doesn't move, because that's what the Psalms say. And then you look at Ecclesiastes 1:5, and it says, the sun rises and the sun sets, and then hurries around to rise again. So if you actually believe the Bible, you'd have to say, okay, well, the earth is stationary, and the sun goes around the earth. And then they say, but then thinking people, scientists like Galileo from a long time ago, he took measurements, he collected data, he used logic and mathematics, and he came up with facts that you can believe in. What Galileo had to do is he had to say, well, the Bible obviously can't be trusted. And by rejecting the Bible's ridiculous stories, finally, Galileo actually found the truth, which is the sun is stationary and the earth goes around the sun. Well, actually, we even know that's not true. Not even the sun is stationary. But that's how the story goes. It basically comes down to this. Galileo and science were right, and Christians and the Bible are wrong. Have you guys heard that story? Many times. It sounds like a great story. The only problem with that story is it's completely false. The narrative is so misleading, they distort so many facts, and I'm going to come back to that at the end of my talk. And by the way, if you said, Roy, what's your position on science and the Bible? This is how, if you're taking notes, and I hope all of you are, this is what I would write down. And by the way, you can email me at the end of this, and I can send you these slides if they're helpful. I would say my position is this. The Bible, correctly interpreted, will always agree with science, correctly interpreted. Okay? The Bible, correctly interpreted, must, I would even go maybe stronger than this, must always agree with science, correctly interpreted. All right, now let's go through a couple of principles that I've learned as in 30 years of research and development in the high-tech industry of semiconductors, and try and apply that to apologetics and Christianity, that I think this will actually make you a better Christian if you follow these principles. They're scientific principles, but it'll help you in your faith and in your walk. What I'm going to do is I'm going to walk through each principle in science, give you an example from my career, and then we'll apply that to our Christian faith. And don't worry, I will follow up at the end with the true story of Galileo, so all of you are going to be armed to say, wait a minute, that's not how the story really goes. Let me introduce the first principle by asking you a question. What do you think is usually the most difficult part of solving a hard problem? Go ahead.
Defining the problem in the first place.
Defining the problem in the first place? You must have a background in some kind of technical something or other. Go ahead.
Keeping your opinions out of it.
Keeping your opinions out of it? Anyone else?
Deciding how to go about solving it.
Deciding how to go about solving it? Sometimes people will say, in the back?
Also, being diligent enough to get to the root cause, which takes a lot of hard work.
Oh, yes. You guys are all technically minded already, I can tell. A lot of times when I speak to a non-technical audience, they'll say, well, like, you have to be super creative and come up with all these amazing ideas. That's like, if you're trying to solve a really hard problem, you have to be super creative and super smart and brilliant and all this kind of stuff. That's actually not the hardest part of solving a problem. Like the gentleman in the first row said, it's a lot about defining the problem. Let me give you a couple of quotes. Abraham Lincoln said, give me 6 hours to chop down a tree, and I'll spend the first hour. How long would you spend sharpening the axe before you spent the rest of the time cutting the tree? An hour, 5 hours. Abraham Lincoln said 4 hours. So 2/3 of the time to solve a problem, he'd make sure he was doing it the right way and had a sharp axe. Another good one is Albert Einstein said, if I had an hour to solve a problem, I'd spend blank thinking about the problem and blank thinking about solution. Albert Einstein, one of the most brilliant scientists ever, he had an hour. How long would he think about the problem? How long about solutions? Half and half, maybe 45 minutes. He said 55 minutes. He would spend this is one of the most brilliant scientists ever, 55 minutes talking about the problem, 5 minutes thinking about solutions. So if you're keeping notes, principle number 1, correctly defining the problem is often the hardest work. Now, I told you I've been doing this for almost 30 years. Like, my kids used to ask me, like, okay, Dad, what do you do at work? And I gave them some, very technical answers, and they're like, what does that even mean? Like, do you, like, put out fires? Do you, like, bake bread? What do you do to, like, make money? And I finally said, I solve problems. And they're like, and they pay you to do that? I'm like, yep. And I would say over my career, I have solved hundreds of difficult, complex problems by using a very structured, analytical problem-solving approach. In fact, years ago, I actually developed my own curriculum with problem-solving techniques that I have taught to hundreds of engineers over the last couple of decades from different companies and across the industry. Step number 1 is always defining the problem. I usually teach that class in about 3 hours, so we're going to cover it in about 1 minute. It looks like this. I'm going to give you, I think it's 5 different ways, okay? Number 1, write it down. You would be amazed. So I'm often just to give you a picture, a mental picture of how this looks, I'll walk into a room, there'll be 20 PhDs, world-class experts in whatever it is that we're working on. And I'll say, okay, what's the problem? And they'll say, well, let's not worry about wasting our time on the problem. Let's just jump to the solutions. We already know what the problem is. And every single time I'm like, great, here's what we're going to do. And I'll pull out a $100 bill and I'll say, if you guys, we have 20 people in this room. We all know what the problem is, right? Everybody just take out a sheet of paper and write down the problem. And if your problems are all the same, I will give every single one of you $100. And they're like, oh, this is the easiest money I ever made. So they take out the thing and they all write it down. Always, in a room full of 20 people, I have 20 completely different problem statements. Every single time. So you might be like, yeah, of course write it down. This is actually probably the most innovative part of it is write down the problem. Number 2, ask a lot of questions. As you're trying to figure this out, you're like, wait a minute, is it like this? Is it like this? Is it like this? Ask a lot of questions. Third, use very precise language. Anytime people are like, yeah, it's something like kind of ish, you will never solve the problem. You have to be very, very specific. Use very precise language. Make sure everyone agrees on the definitions. You would be amazed in a group of engineers and scientists, the language that they use. They're like, yeah, we all know the definition of that word. And I'm like, great, write down the definition of the word that we all agree on. They'll write it down, and they all have completely different definitions. And then the last one, and this is my favorite, I have 7 kids. At some point, we homeschooled all of them. I said, do a 5th grader test. If you can't explain the problem to a 5th grader, you do not understand the problem. This is usually the most offensive thing as I teach my class. They're like, how dare you, I'm a PhD, I'm so much smarter than everybody on the planet, I wouldn't waste my time explaining this to a 5th grader. Then I look them right in the eye and I'm like, then you don't understand the problem. Okay? All right. Let's use a real world example and show you what this looks like. First, I need to give you just a teeny bit of background on how computer chips are made. I'll go quick. So computer chips are about the size of your thumbnail. Okay, that's about how big they are. They are made on a glass plate called a wafer. Usually there's hundreds or even thousands of these chips on a wafer. And you test, to see if they're good, you test these chips by using what I'll call probes, little metal wires that are like as big as your eyelash. Thousands of them come down on your thumbnail all at the same time. The little pads that they come down are smaller than a grain of sand. And then they deliver a bunch of electricity on and off and on and off at like crazy high speeds. And they tell you if it's a good chip or not. Crazy, crazy stuff. Here's a picture of what the little probes look like. Okay, thousands of these on a thumbnail. They all come down on grains of sand, and then electricity goes back and forth. Our industry was dealing with a certain problem for over 10 years. Basically, these little metal wires, they were coming down, and while they're trying to do this one particular test, they were all like blowing up. Sound like a problem? Yes. It was only costing us millions of dollars a day to deal with this problem. So it wasn't that big of a deal. So first thing I did was define the problem. Which wires were blowing up? Which wires weren't blowing up? When were they blowing up? Why were the ones not blowing up? How were they blowing up? What do you mean by blowing up? All these kinds of things. I spent 3 months flying all around the world, talking to engineers, defining the problem. Took me 3 months. And basically, at the end of it, I had a problem statement. And I said, okay, now what's the answer? And people are like, I have no idea. We didn't even know what the problem was. It was basically, just to give you an illustration, it was basically like taking a Ming vase, putting it in a black garbage sack, putting it in a closet, shutting the door, leaving your house, coming back, opening it up, the black garbage can, and the vase was broken. And they're like, why'd that happen? And people are like, I have no idea. We weren't even here. We didn't even see it. So here's what my team did. I said, you know what, even though we've written down the problem statement, we still don't even understand it. So I said, team, first thing we're going to do is we have to understand what's going on. So we invented a little robot that was about the size of an ice cube, and we put it right at the wafer when the probes were coming down, when the electricity was going back and forth, it measured mechanical and electrical and thermal and physical and all this kind of stuff. And then we said, okay, now go. And it was taking all this data, and we turned it on, and they all blew up. And then we said, okay, great. Now let's watch the video and look at the data. And it was amazing. Nobody guessed the root cause. I think somebody in the back said, you got to find the root cause. No one had even imagined what the root cause of what was going on. And as soon as we found it, it took us about a week to solve it. So 10 years, nobody even knew what was going on. 3 months to define the problem. Once we had it, a week to solve it. Yeah, exactly. That is top secret. Okay, so let's move on to, and I am serious. So I deal with all kinds of intellectual property, and so I'm going to, kind of generalize this, but it was an amazing thing. So correctly defining the problem is often the hardest work. Now, let's apply this to our Christian walk, apologetics. I'm amazed at how often Christians get tripped up in apologetics with this exact thing. They don't know the problem that the question that they're trying to answer. So let's try one. Ready? How can a good God exist when so many bad things happen to good people? Has anybody ever heard something like this? Yep, again, 100% of the people. Yep, all the time. When you heard this question, how did you feel? Defensive? Attacked? Yeah, trapped, cornered, I have no idea how to do this. Yeah, there you go. The problem is, if this is really the problem statement, we are trapped. We can't answer this. So if you're like, wait, something's wrong, those are great instincts. You're on the right track. So let's walk this through quickly. The first thing that you should notice are the words good and bad. They imply some kind of universal standard. So, and now you're like, wait a minute. If there was an objective moral standard by which we could classify something as good or bad, where does that universal standard come from? Well, that universal standard that's outside of us, doesn't that sound a lot like God? So you're saying, wait, in order to even ask this question, I presuppose that there is a God that gives me good and bad. Well, now wait a minute. If my presupposition is that God exists, to even ask the question, can I ask the question, how could God exist when this happens? No, I've already defeated the question. You see the obvious fallacy. It's an incoherent question. And in my time of apologetics for the last 10 years, 98% of the question, maybe 99.9% of the questions that I first hear are incoherent questions. Now, can you answer an incoherent question? No. So we waste a lot of our time with incoherent questions. So instead of saying good and how can God exist when so many bad things happen to good people, what we should say is, how can a good God allow so many bad things to happen to good people? Do you see the difference there? It's a subtle difference. That's why we use very precise language. I'm presupposing that God exists so that there are good and bad categories. But how could a good God allow that? Now we're having a conversation. Now we lead to things like, why is there so much suffering in the world? Can there ever be a good purpose to suffering? Shouldn't there be some kind of grand cosmic reckoning that will make everything right in the end? Sure, now we're asking good questions. Now we're in a good conversation. A conversation that can ultimately lead to the gospel. and lead to sharing Christ and lead to salvation. All because we changed a few words in the problem statement. Okay? All right. Let's talk about another one. Why don't Christians believe in the obvious science of evolution? So, what should you key in at, and we're going to move fast on this, all right? We'll post this to our website at the end. So if you want to be like, well, we were going so fast, I'll send the slides to you. You can get our email later. So what you should focus in on this is the word evolution. What do they mean by that? Well, did you know that the word evolution typically has at least two common definitions? The first one is microevolution. Animals adapting to their environment and thus producing limited variation within a species, based on inherent information possessed in their DNA. Does anybody have a problem with this as a Christian? Does the Bible have a problem with this? No. Great. This makes sense. The issue comes when you talk about macroevolution. Macroevolution is an alternative origins theory that includes a common ancestry of all species and often used to justify that God doesn't exist. Every Christian, every Bible-believing Christian should have a big problem with this. So you can see if somebody says evolution, your first question should be, wait a minute, micro or macro? Because if you're talking about micro, we're in agreement, no problem. If you're talking about macro, it's a completely different conversation. Okay, I spent a ton of time on this first part because step number one, correctly defining the problem is so important. Never skip it. Principle number two, everyone always has presuppositions. Everyone. Now, what do I mean by a presupposition? I mean an assumption that you make at the beginning, something you assume to be true even though you can't prove it. Let me give you an example. Let's pick something that doesn't have presuppositions, like math, right? Math is just like what it is. You don't have to assume anything to get to math, right? Like 2 + 2 is 4. You don't have to like presuppose anything for that to work. Right? I don't know. Let's see. Let's take, anybody ever heard of Euclid? He is the father of geometry, okay? So for you young people, if you're ever like, who do I blame for like my silly geometry homework? It's this guy, okay? Now, what he was trying to do was prove that, like, hey, if a triangle is the same as another triangle, then the sides are equal and stuff like that. Or if perpendicular lines never meet, blah, blah, blah. And so he's like, you know what? In order to just prove the basic fundamentals of geometry, math, he had to make several assumptions that he could never prove. But they were probably pretty simple, right? Like, a straight line may be drawn between any 2 points. Pretty simple, right? A second one, a line segment may be extended into an infinite line. Pretty simple, right? A circle may be drawn with a center and a given radius. Yeah, okay, Uncle Euclid, these are pretty simple. All right angles, which are 90 degrees, all 90-degree angles are equal to other 90-degree angles. Right? So you're like, okay, dude, seriously? Like, you're just pointing out the common sense. So he's like, all right, I'm going to make some very obvious observations like this. And then he went to try and prove that a triangle could be like the same as another triangle. And he found he couldn't do it. He's like, even with these simple assumptions, I can't prove basic math. So he's like, all right, there's one other simple presupposition or axiom that I need to add. One other simple thing, common sense, everybody gets this, right? If two straight lines in a plane are met by another line, and if the sum of the internal angles on one side is less than the two right angles, then the straight lines will meet if extended sufficiently on the side on which the sum of the angles is less than two right angles. All he was trying to prove was 2 + 2 is equal to 4. And he's like, I can't do that unless I make some pretty fundamental presuppositions. Crazy, right? Okay, but that's math. I mean, science doesn't have any presuppositions, right? So it turns out that David Hume, a famous atheist philosopher in the 18th century, found what he called science's hidden assumption. It's something that science has to assume to be true, but it can't prove itself. And that is, it's really complicated, that tomorrow will be like today. Anybody think that's really, really hard to understand? No. It basically means that the laws of nature won't change. Philosophically, scientifically, you can never prove this. But it has to be true for science to work. So you're like, wait a minute, I'm going to do this science with something that science can't prove. You're like, uh-oh, we're in a bit of a pickle. Right, that's because everyone always has presuppositions. So the next time you're in a conversation with someone and you're like, well, I believe the Bible is true. And they're like, well, you can't prove it. Are you at a disadvantage? No, because guess what? To know anything, you have to make a presupposition. So it's not a matter of, well, Christians have to presuppose things and scientists don't. It's a matter of everybody always has to make presuppositions. It's just a matter of if those presuppositions are reasonable. Let me walk you through another example. Has anybody ever heard of circular reasoning? All right, let me give you a picture of what it looks like. Circular reasoning works because circular reasoning works. Because circular reasoning works. Because. Here's another one from Dilbert. So Dilbert's saying to Dogbert, and we know that mass creates gravity because dense planets have more gravity. And Dilbert's like, or Dogbert's like, well, then how do we know which ones are more dense? And Dilbert's like, well, because they have more gravity. And Dogbert's like, that's circular reasoning. I just prefer to think of it as no loose ends. Okay, let me walk you through a scientific example here. In my day job, I work with something called MEMS, electromechanical systems. Has anybody ever heard of that? Okay. Super, super, super cool. You can Google it later. It's like Legos, but like really, 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 really small. But you can make like on the left, see on the left there is like, I think it's a clutch. On the right is this little complicated system. And we're really zoomed in. Okay, so I'm going to take a piece of human hair, just to give you a scale, and I'm going to put it like on this picture. So you get a size, an idea of how big these are, right? Yes, that's how tiny they are, okay? So we were using a MEMS process to make cool, crazy stuff like this. And we were using a really complicated, you guys have probably never heard of this metal. It's called gold. Do you guys know anything about gold? Okay, I'm going to give you a quiz. Here we go. Is gold valuable or worthless? Valuable. Not valuable. Okay, good. Is gold heavy or light? Heavy. Heavy, okay, good. Is gold soft or hard? Soft. So, pure gold is really soft, like softer than some woods. Okay, so you're right. Pure gold's really soft. Do you know that's why when somebody like wins an Olympic medal, they actually like bite it? Because they're like, I wonder if it's real gold. Because if they bite it and then they're like, good, there's my teeth marks. That's real gold. Thank you, guys. But did you know that if you mix in other stuff, not even a lot of it, just a teeny bit of other stuff, gold can become hard, like really, really hard. Like 10 times harder than soft gold. Okay? So I won't get into all the details, but what we were working on a problem, and we were building these things, and with our MEMS process, we had correctly defined the problem, we were working on solutions, and then we were like, our solutions are just not working. And we're scratching our heads, and we're like, what is going on? We're using the gold, and we're trying to do this, and it's not working. And we're like, well, maybe we fell into some black hole vortex where the laws of physics don't work anymore. You think that was a good idea? No. We were like, wait a minute, that we must have made some assumption that was incorrect. And so we went back and looked at it, and we thought we were using hard gold, because at our company, this certain line, that's all we ever did was used hard gold out of this one line. And we're like, of course we're using hard gold. Why isn't it working? And then somebody's like, hey, is it even possible that somebody might have mixed up the recipe and we actually made soft gold? They're like, no, that's ridiculous. That would never happen. And for a couple more weeks and a couple more months, we're like, why isn't this working? Why isn't this working? And finally the guy in the back's like, could we just check if we accidentally... And somebody's like, seriously, okay, whatever, go waste your time. And he came back and he's like, hey guys, somewhere in the recipe, we accidentally mixed it up and we're using soft gold. And we're like, oh, well, let's try hard gold. And as soon as we tried the hard gold, immediately it worked. And it all came back to our assumption, our presupposition. Okay, let's apply this to the Bible. We talked a little bit about this. When Christians are met with the task of proving that the Bible is true, it's okay, you have to have a presupposition, but what logic do they use? They say, hey, the Bible is true because it says that it's true. What do you guys think? The Bible is true because it says that it's true. Therefore, the Bible is true because it says that it's true. Couldn't you do that with anything? Could I just write a book and say, this book is true? Would that make that book true? No. In my book, yeah. So, I won't have anybody raise their hands, but if you've ever used this defense of why the Bible is true, don't do that anymore. Okay? I'll give you a better one. The Bible is true because... And now we've got some reasonable logic that we can defend why the Bible is true. And I'm going to go through these super quick. I have a whole other talk on this. I'll give you 3 super quick answers. Way better than the Bible is true because it says it's true. Number 1, it was confirmed by a supernatural event. 10 Commandments, when God gave the first part of the Bible, the 10 Commandments that he wrote with his finger, did you know that there was 2 million eyewitnesses and ear witnesses to that event? 2 million people watched God write the Bible. Okay? Number 2, its explanation best fits reality. So philosophically, there's some really, really good answers that only the Bible, no other religious book gives that fits reality. Things like creation. Where did everything come from? Morality, sin, redemption. The last one is Jesus said the Bible was true. Now, how do we know Jesus was accurate and an authority? Well, let's see. He rose from the dead. He did a bunch of miracles. He fulfilled prophecies. He changed the entire course of human history. It's why today is 2024. So Jesus is always a big deal. All right, I'm going to keep moving on. Presuppositions. If that's for me, tell them I'm busy. There are worldviews that are opposed to Christianity. Now, what presuppositions do they make? And I'm going to go through these super quick because I think we're using more time than I thought. I'm going to just probably blow through these. Again, you can ask for these slides later. Non-Christian presuppositions are scientific naturalism. All things can be discovered through science. Not true. Materialism, the material world is all that exists. Not true. Relativism, there is no absolute truth. Not true. Even laws of logic, like if A equals B and B equals C, then A equals C, you can't prove those. Those have to be presupposed. So again, everyone always has presuppositions. It's just a matter of if those presuppositions are reasonable. My third point is going to talk about the scientific method. For those of you who are like, oh, really? I suffered through like my high school class of science. Here we are again. I'm going to go through it super, super quick so my last point makes sense. Scientific method is make an observation. Propose an explanation, which is called? Hypothesis. Good job. Then you create a prediction. Then you collect data to see if your results match your predictions, called experiments. Good job. And then, are you always right the first time? No. So last, you modify your hypothesis to better match the data. That's what's called theory. So science has a little secret. We talked about this a little bit, but let me make it very explicit. How much do you think science can prove? Like everybody, when you walk around, they're like, well, yeah, but I'm a scientist. I need proof. I need data. I don't just believe in religion. How much can science prove? Science never, ever can prove anything. It can't. It's not designed to. Now, I'm using very, very precise language. What can science do? Science can disprove things. Science disproves things. So you never know if you're right in science. You only know if you're wrong. Again, 30 years, I do this every single day. All we ever do is disprove things. And then what you're left over is you say, hey, I have a hypothesis that I have not yet disproven. And we call that a theory. We assume it to be true, and then we run our experiments. So principle number 3 is look for the fatal flaw. You only need to find one thing that proves it not true, and then you're done. A lot of times people look for dozens or hundreds of reasons why something's not true. You only need one. Okay, I have another question for you. What do lightning and a magnet and a rainbow all have in common? Lightning and a magnet and a rainbow all have in common.
They're all something.
They are all something. Did you guys know that they are all forms of the same energy? So lightning and a magnet and rainbows are kind of all like the same thing. It's called the electromagnetic spectrum. And if you haven't studied it before, I don't know how you're living your life. This is like the most exciting, cool thing ever. Dig into this. Look up the electromagnetic spectrum. It is so, so, so cool. And when I dug into this, it took me years to get my footing. But once you see what God did here, you're like, oh, God, you created the most amazing, intricate design ever. So why do I bring this up? Because in my job, there was a company that said, hey, Roy, we've invented a way that science, using the fact that lightning and magnets and rainbows are all the same energy, we can do something impossible. And I'm like, dude, so cool. Show me how this works. And it had to do with the chips and the little probes and all that kind of stuff that we talked about. So they were like, hey, I've got lightning. I'm going to mix in a little magnetic stuff. I'm going to make it a rainbow at the end, and it's amazing. And it worked. Now, here's the cool thing. On this part, their solution, it really did what they said it would do. They used a little bit of magnet and a little bit of rainbow. and a little bit of lightning, and they did something impossible. That seemed like it was impossible. I can't tell you. Now, they were like, oh, there's one small problem. Remember those little probe things? Yeah, that part, they kind of makes those blow up. And I'm like, okay. And they're like, but hey, don't be so negative. Like, don't just focus on the part that doesn't work. Look at the super cool part that works, like lightning and like magnets and rainbow.
Don't look behind the curtain.
Yeah. Now, what would you, they wanted like, not that much money, it's like $50 million. They're like, hey, could you just give us $50 million because look at all this cool stuff we can do. You think I should have bought the machine? But all that cool stuff worked. It really did work. It only had one problem. It blew all those little wires up. No, you wouldn't have bought it. I didn't buy it. Neither should you. All you have to have is one problem with something, and it's done. That's the key. Okay? Now, you would be amazed how often this happens is in apologetics. Let me give you an example. Let's say that me and my atheist friend are having a conversation. And I say, man, what a beautiful world we live in. Where do you think it all came from? And your atheist friend is like, I don't know, probably just from nothing. And you say, wait a minute, so like everything came from nothing for no reason. And they're like, yeah, that's kind of a tough one, but that's pretty much what I believe. Now, you guys all look like awesome, kind, friendly Christians. What should you do in that situation? Should you say, hey, you know what? Let's not be divisive. Let's not focus on the negative. There's one small problem in your worldview, like you kind of think everything came from nothing for no reason. But let's not focus on that. Let's focus on the good. Let's focus on what we agree on. Would you be doing that person any favors by ignoring the fatal flaw in their worldview? No. You are actually being unkind and unloving as a Christian by ignoring the fact that they have a fatal flaw in their worldview. The most loving thing you could do is say, hey, wait a minute, you got a major problem. We have to deal with this. That's the most loving thing you can do. Okay, let's go back to a quick review. Here's our principles. Correctly defining the problem is often the hardest work. Everyone always has presuppositions. Don't let that be something that they accuse you and say, yeah, but you're believing the Bible is true. You're like, well, you're believing something too. And always look for the fatal flaw. Look for the one thing that's like, wait a minute, something's broken, and do not leave that one thing. Okay. Another way to think about this is, what's the problem statement? What are your assumptions? And what's the fatal flaw that proves you wrong? Now, let's go back to Galileo, and we will finish this up. What was the problem statement that Galileo was trying, and the church were trying to figure out? Usually, people, the way the narrative, remember in the beginning I told you the story? Usually it's captured something like this. The church believed that the sun revolved around the earth because the Bible clearly taught that, right? I went through Psalms and Ecclesiastes. Now, when you look deeper into this topic, you find that that problem statement is not true. Okay? The reason, did the church believe that the sun revolved around the earth? Is that what the church really believed? Yes. Did they believe it because that's what the Bible taught? No. So when you look into the data, it's actually that idea. There was science behind the earth, the sun going around the earth. Back to Aristotle and Ptolemy And throughout the Middle Ages, that was the accepted scientific theory of the ancient world. I'm not going to get into the explanation. Maybe catch me in the gym afterwards if you want to talk science-y stuff and geek out. But I'll just give you one simple example. There's something called parallax, which if you look at something and then you look at it from a different angle, it ought to move. And with the best telescopes and looking up in the night sky that they had, they're like, wait a minute, when we look at the stars, they don't move as much as we thought they would if the Earth was moving around the sun. It had to do with the fact that they weren't making good observations. So there was a scientific reason why all the scientists at the time were like, you know what? I think the Earth is in the middle and the sun's moving around us. It's not because of the Bible, it's because of science. That's what they believed. So, what is our true problem statement? The church believed the sun revolved around the earth because that was the scientific consensus at the time. Very, very different than the story we're often told. Now let's apply principle number 2 to Galileo. What are the assumptions embedded in the narrative? They said Galileo's new theory of the earth revolving around the sun was the result of new scientific data. So they're like, nobody ever thought of this. Ancient people, because all they had was the Bible, they thought that the earth revolved around the sun. And then Galileo came up and said, hey, I took my telescope, I gathered some new data, and I came up with a new theory that it's actually the earth that goes around the sun. Was Galileo's theory new? No. It had actually been around for over 1,000 years and actually goes back to Pythagoras and Copernicus. So there has been competing theories, scientific theories, about which one goes around which one. By the way, those of you who aren't in science every day, that's the way science works all the time. Science is constantly changing its theories. I'll give you another quick example. It used to be when I was in high school, they're like, an atom just has a proton and a neutron in the middle, and the electrons go around in a circle like this. That's what I was taught. And then later they're like, yeah, that's kind of not really how it works. And we're like, what? I thought we had science behind that. And now they're like, well, so where's the electron? And they're like, you kind of don't ever really know where the electron is. And they're like, what? It kind of is here, and then it might be over here, and it's probabilistic, and it gets crazy. But that's where science is today, and probably they'll disprove that pretty soon and come up with another crazy theory. So science is always evolving. So the fact that they didn't have it figured out, that's how science works. Okay, what about the third principle? What's the fatal flaw that proves you wrong? The driving force in this narrative, as how it's usually spun, is that they say Galileo was trying to prove the Bible wrong with science. Galileo is on one side and the church is on the other side, right? That's how you guys have all heard the story? Now, is that true? No. Did you know that Galileo was a super devout Christian? Like he was like, hey, Bible, go Jesus. He was a brilliant scientist who was humble before God in awe of his works. Let me prove it to you. This is a quote from Galileo. I want you guys to all memorize this quote. Okay? Here's the quote. Memorize it. Here's Galileo. He actually said this. Right? Remember this. Well, he spoke Italian, so like, come on. Let me translate it into English. This is Galileo, okay? Does this sound like the guy who's like, I want to disprove the Bible with science? He said, God is known by nature in his work and by doctrine in his revealed word. He wasn't like anti-science. He was pro-God. Okay. Whew! We ran through that super fast. Let me give a quick summary and wrap up, and then I have 45 minutes, an hour and a half for questions, or maybe 3 minutes. Okay, we screamed through that. if you forget everything we talked about with science and the gold and MEMS and all that kind of stuff, here's the part to remember. If you guys are smarter because of this talk, I hope you are, what should you do with that? Should you rush out and start beating up your friends and saying, hey, I learned this about Galileo, you're stupid, you're an atheist, you're wrong? No. No, don't do that. Apologetics, and if I generalize it, Christianity in general, is about taking truth and bringing it to people humbly, gently, respectfully, and saying, hey, I didn't know a lot of this stuff. Can we think through this together? I'd like to hear what you say, what you think. I'd like for us to think it through together. Here's some things to consider. That's what you as a Christian, if you're doing any kind of apologetics, that's the approach you should take. 1 Peter 3:15 says, but first, in your heart, revere Christ as Lord. And if anybody asks you a reason for the hope that's in you, give a defense. With what? Like a big hammer and like yell and scream? No. Give a defense of what you believe if someone asks with gentleness and respect. That's the key takeaway. All right, 3 minutes if anybody has any dying questions. Thank you, guys.
What's your website for getting this?
Good. So the website, and we should put this on here. I don't know if I have it. No. It's called, and we have a booth in the gym. It's called The Ambassadors, with an S, theambassadorsforum.com. Theambassadorsforum.com. And I think it's in the Mission Connection thing. So we have a bunch of good materials on our website. Drop by and talk to us at our booth. We have a bunch of events where we come and talk to schools and youth groups and churches and host small events for teenagers with pizza. Because, like, can you do anything as a teenager without pizza? All right, any other questions? In the back.
So, to me, after the main session as well as listening to this, my question is, why do people see things differently? So, for instance, Sean McDowell had dinner last night with an atheist. They were very cordial.
Yep.
Neither of them changed the other's mind.
Uh-huh.
But, so the question is, why do people hear the same message, like in Acts 17,
Yep.
but have different responses? And when we see that we have a difference, we tend to get mad at the other person, not with ourselves.
Perfect. Great question. So I'll repeat it. Why do people looking at the same data come to different conclusions? And also, if somebody else has a different opinion than us, typically we assume they're wrong and we don't even consider the fact that we might be wrong. Does that capture it? Yeah. Okay, let me answer the second one first. I hope all of us as humble, God-fearing Christians, when we hear somebody say something that disagrees with us, I hope we would be open-minded and say, I might be wrong. That takes a lot of humility. I think the reason it doesn't happen to just call it out is because we as Christians are not as humble as we should be. And I'll number one, me first. I'm not as humble as I should be. Number two, I think the reason why people look at the same data and come to different conclusions goes back to their presuppositions. So they don't take the time to think through and say, wait a minute, do I have a worldview that makes sense of the world? We as Christians do. And by the way, there was a new Barna study that just came out. The number one worldview in America, 96% of the people in America believe this worldview. And it is something that contradicts itself. So 96% of the people in America have a worldview where they're like, hey, I believe black is white, and white is black, and good is evil, and evil is good. That's what their worldview is. So when we go out into the world, we should say, wait a minute, does your worldview even make sense? Like, just describe to me your worldview, or does it contradict itself? In about 5 minutes, you ought to be able to say, agree with them. It's been my experience. They're like, oh my goodness, I never thought about that. Like, what I think contradicts what I think. And I'm like, that's kind of crummy. And they're like, yeah. And they're like, well, what do you believe? And I'm like, I just believe the Bible. And it kind of says this, which aligns with this, and kind of all makes sense with this. And usually they're like, wow, that's pretty cool. The Bible, like, forget all the stories and all the complexity and like 9,000 pages of, 66 books and all this kind of stuff. They're like, I never thought about the message of the Bible just being clear and consistent and matching reality. If you can just get that far in a conversation with somebody, you've already established a great place to have further conversations.
And Satan has a lot to do with it.
Yes, and then there's a whole thing about God and all that stuff.
I think.
Hold on just a second. We are out of time. I wanted to say thank you, everybody, for coming. And we all got crammed into this little room. Again, the website, find us in the gym. I'm going to be hanging out here for a while. If you have other questions, I'd love to talk to you. But thank you guys for coming.
I was just going to say that we're talking about reading the same data and coming up with a different solution.